In this video, we're going to take a look at proofs with factoring where we are using logarithmic functions. So our example here says ln of x squared plus 5x plus 6 plus ln of x squared minus 4 minus ln of x squared plus x minus 6 equals 2 times ln of x plus 2. So if I want to prove that this is true, I am going to choose one side and then manipulate it using the skills that we have in order to try to make it equal the other side. Now, when I'm trying to choose a side, I notice there's a lot more on the left side than the right side. I see on the left side I have addition and subtraction, and I have 3 different terms that are being added and subtracted. On the right-hand side, I have 1. So if I choose the left side to work on, I'm going to have to find a way to combine those into one term. If I choose to work on the right-hand side, I'm going to have to find a way to take that and break it up into 3 separate terms. And I think that would be a lot harder, so I am going to choose the left side. So this is ln, which is log base e. E is Euler's number. It's like 2.71, just keeps going. All right, so we have x squared plus 5x plus 6, and then plus ln of x squared minus 4, and then minus ln of x squared plus x minus 6. Okay, well, our goal is to try to get this down to 1 log. Now, what is promising is that they all are ln, so they're all the same base. They're all base e, which makes it easier because that means I can use log rules. Now, if I look at my list of log rules, I do have log rules for addition and subtraction. The addition rule says that we can combine or merge 2 logs into 1 by multiplying their arguments if they have the same base. And then the subtraction rule says that we can merge them into 1 by dividing those arguments. So we are going to go left to right following our regular order of operations. We have addition and subtraction, so I'm just going to do whichever one comes first. So when I add together 2 logs, we can merge them by multiplying their arguments. So I'm going to have ln of, now I'm not going to start multiplying, I'm just going to write what it would look like as a multiplication question. So I have x squared plus 5x plus 6. And then times x squared minus 4. And we're still subtracting ln of x squared plus x minus 6. I am going to have to do something with this, but I think I'm going to wait and I am going to merge these together. So I'm going to divide in order to do that. So I'm going to have x squared plus 5x plus 6 times x squared minus 4 divided by x squared plus x minus 6. Okay. So at this point, I managed to get it into 1 single log, right? But the argument here is way more complicated than what is on the right-hand side. So I'm guessing my argument is probably going to reduce. Now, I could multiply out the numerator and then try to factor, but it's already partially factored, right? It's a multiplication question, which is what factoring is. So if I could factor each of these individual expressions, I could then look to see what they have in common that I could divide out. So that's what I'm going to do. So I'm going to go and factor each of these. I might do that off to the side, just a little out of the way here. So I've got x squared plus 5x plus 6. This one I could use the shortcut for a trinomial. So I'm looking for 2 numbers that multiply to the first and last, which is 6, and add to the middle, which is 5. 1 and 6 would subtract to give me a 5, but if I do 6 take away 1, 6 times negative 1 is negative 6, and it doesn't quite match. 2 and 3 also add to 5, and they multiply to give me positive 6, so I'm going to pick 2 and 3. So I have x squared. Oh, actually, it's the shortcut. So I can just use x plus 2 and then x plus 3. Otherwise, I would need to use decomposition. Okay, that's the first one done. X squared minus 4. That one has two terms. It does not have a common factor, but they are being subtracted and they do have a square on them. This is a difference of squares. So I can square root and use the shortcut. So square root of x squared is x. Square root of 4 is 2. And then one bracket is plus, one bracket is minus. And then my last one, the x squared plus x minus 6, is also a trinomial that I can use a shortcut with because there's nothing other than a 1 in front of the x squared. I would multiply. That one gives me negative 6, and they need to add to 1. So a 6 and a 1 is not going to add to a 1, but a 2 and a 3 would if the 2 was negative. And since there's no coefficient, this is just x minus 2, and then x plus 3. Okay, I'm going to take all of those and put them back into our expression. So here we're going to get ln of, I've got x plus 2, x plus 3. That's the x squared plus 5x plus 6. The x squared minus 4 is x plus 2, x minus 2. And then in the denominator, that one factored to x minus 2, x plus 3. Okay, so looking at this, I do see that there are some things that show up in the numerator and the denominator. I see that there is an x plus 3 that shows up on the top and the bottom. There is also an x minus 2 that shows up on the top and the bottom. So this next step you do not have to write in, but I am going to kind of split it up to organize my brain a little. Looking at this, I notice that I have an x plus 3 on the top and the bottom. I've got an x minus 2 on the top and the bottom. And then I've got an x plus 2 times x plus 2. So out of all of that, the x plus 3's dividing by itself just makes a 1. And then the x minus 2's also just makes a 1. 1 times 1 is 1, and 1 times anything is just itself. So it's just going to be x plus 2, x plus 2. I can write that in a different way. X plus 2 times x plus 2 is actually x plus 2 squared. Now, you could put an additional bracket around that. It is not necessary at this point, right? You could just leave it as x plus 2 squared and not put the extra bracket. I feel like we're getting close to what's on the other side. I will come back, but if you take a look here, I have 2 ln x plus 2. Here I've got ln of x plus 2 squared. So the bracket part is right. It's just the exponent that's not. There is a log rule here that says if you have an exponent on your entire argument, not just one part, but the whole argument, you can bring that down out front and multiply. So this 2 is on the whole x plus 2, so I can bring that down out front. And that's going to be 2 times ln of x plus 2, which is what is on the other side. So left side equals right side. Okay, so you have the rest of the period to work on your proofs with factoring practice.